Greetings, fellow mathematicians. We're going to take a look at a really important differentiation rule known as the power rule. Now, before we state this rule, let's understand what a power or power function is. So we're typically going to be using in Calculus 1 x as the independent variable. So a power function would look like x raised to a number. So in general, what we're calling a power function is a variable raised to a number. X is the standard independent variable. The other one, which you're likely going to encounter in your Calculus 1 course, is using t as the independent variable. And that would look like now for a power, t raised to a number. Now with that out of the way, identifying a power function, a variable raised to a number, let's go ahead and state the power rule. And it's a rule for differentiating a power of x or a power of a variable. So if our function here is x raised to a number n, what the power rule says is we take that power n, we bring it down out front, and then we subtract 1 from the exponent. And that is it. So again, what this rule says is we bring the power down and then subtract 1 from the exponent. And again, that's going to work if we're using x as the independent variable or t as the independent variable. You could use any other variable that you want, but x and t are the standard ones. So again, take your power, bring it down front, subtract 1 from the exponent. Here, using t as the independent variable, power rule says the same thing. Take your power of the variable, bring it down front, and then subtract 1 from the exponent. And that is it. What might have taken you hours worth of work with the limit definition of the derivative, you can now calculate derivatives for powers in seconds. So let's go ahead and take a look at some standard examples so that way you can understand how to use the power rule. All right, so let's start with the simplest power of x, just x, but make sure you can identify that as being x to the 1. All right, and if we go ahead and apply the power rule, what the power rule says is we're going to bring the exponent down front. So we bring the power 1 down, and then we subtract 1 from the exponent. 1 minus 1 gives 0. Anything to the 0 power is 1. So what we get here, the derivative of x, or the derivative of x to the first power, that derivative just comes out to 1. All right, that's really simple. You're going to be using that derivative, the derivative of x, coming out to 1, in a lot of other problems that follow. All right, let's go to, let's say, the derivative of x squared. We're going to, again, apply the power rule. So we take the power 2, bring it down front, and then we get x to 1 power less. So we're going to have now the power of x as 2 minus 1. And we get as our answer here 2 times x to the 1, which we can just write as 2x. All right, let's go to the next power of x. Let's say x cubed. You can probably see the pattern here. We're going to bring the power 3 down. And then we subtract 1 from the exponent. And we get as our derivative of x cubed 3x squared. All right, that's probably the limit of where you'd be asked to apply the limit definition of the derivative, stopping pretty much with x cubed. Anything beyond that, applying the limit definition to, let's say, x to the 4th power, that would be brutal. Now, let's suppose you want to find the derivative of x to the 100th power. Good luck doing that with the limit definition. That might take you all week. Now, we'll get it in seconds. So let's apply the power rule. We're going to bring the power down 100. And we just now get x to 1 power less. 100 minus 1, we get x to the 99th power. And again, the work here in calculating that derivative with the limit definition, that would take hours, if not weeks. Here, Using the power rule, we get that derivative in seconds. This is a true, legitimate shortcut. All right, now these are all basic examples. Let's go to some more peculiar powers which still apply, because here your power rule will work if the power n is any real number. Typically, you'll be applying the power rule to these nice powers that are going to be positive integers, but you don't have to. You can apply the power rule when it's x raised to any real number. So let's suppose we were differentiating x raised to this peculiar power, x raised to the 2.138 power. Well, the power rule still applies. We're going to bring that power down. So we bring down 2.138. And we're going to subtract 1 from the exponent. And I'm not really good with basic arithmetic, but if you take 2.138 and subtract 1, you'll get 1.138. And there we go. The power rule still applies when your power is maybe some decimal value. All right, you can also apply the power rule if you have a real number like x raised to the pi power or x raised to the e power, where e is Euler's number, pi is approximately 3.14, e is approximately 2.72. Now, these examples are just meant to test your understanding of the power rule. You probably won't encounter these in a lot of Calculus 1 problems later in your course, but they are still good to understand. So how would we apply the power rule here? We're going to apply it exactly the same as what we've been doing. So here we have a power function, x raised to a number. We bring the power down, so we're going to bring down pi. And now we get x to 1 power less. And we're just going to write that power as pi minus 1. And we're going to leave it like that. It's pretty standard and typical in a Calculus 1 course where possible, you'll leave things in terms of exact values. So here, leave it in terms of pi. Don't plug in pi as 3.14. All right, so once you understand the power rule and how to apply it, that example is actually really simple. No more complicated than any of the other previous ones. Now let's get to the last basic example. This is meant to confuse you a little bit later when you get to the derivative of exponential functions, e to the x. But here we have the derivative of x to the e, x raised to a number, that's a power function. So we apply the power rule as usual. We bring the power down front, and we get x to 1 power less. And like the example above, we're just going to leave that power in its exact value. The power here is now x raised to the e minus 1. And there we go. So these are all pretty standard basic examples where it's obviously given to you written as x raised to a number. Now here, we're using x as the variable. Let's take a look at one example just to make sure you understand how to apply the power rule if you had a different variable. So let's suppose as in another example, we'll call this 7.1. Let's say we're differentiating with respect to t. Let's go with t to the 4th. That might be the example that occurs after differentiating x cubed. Well, here the power rule still works if you're using a different variable. Make sure you understand that. The power rule works for any variable as long as you're differentiating with respect to that variable. So here, what we do is we take the power 4 down out front, and we subtract 1 from that exponent, 4 minus 1. We'll get as our derivative 4t cubed. And it's as simple as the other examples. Just make sure you're comfortable using a different independent variable. You're going to see that throughout the beginning of your Calculus 1 course. All right, now with that out of the way, let's take a look at some more complicated examples. And these really aren't complicated, but these are not obviously written as a power of x raised to a number. Now, I'm going to give away a very important technique for calculating derivatives at this point in your Calculus 1 course. The tip I'm going to give: you can have an easier time of calculating derivatives if you first rewrite the function. So the tip is rewrite. So in other words, rewrite your function before you differentiate. And if we keep that in mind here, for this next example, differentiating the square root of x, we can rewrite square root of x as x to the 1/2 power. And at that point, we can now apply the power rule. The power rule will still work if your powers are fractions. So this works if n, the power, is any real number, fractions included. All right, so let's go ahead and apply it. We're going to bring the power 1/2 out front. We're going to bring that down. And now we get x to 1 power less, 1/2 minus 1. You should be able to calculate that no problem, but I'm going to write it out. If you go ahead and simplify that, you get as your power x to the negative 1/2. And there we go. Now earlier in a previous video, which I'm going to have linked down below in the description, we went through the derivative of square root of x by using the limit definition. And it was manageable, but it was a lot of work. Let's just rewrite our derivative in a different form to verify that we get the same answer. First, I can take that negative exponent and put it in the denominator. So I'm going to get 1 over x to the 1/2, or positive 1/2 power. And I'm going to rewrite x to the 1/2 back as square root of x, but now it's in the denominator. And I'll multiply 2 to that denominator. So I can write my derivative here as 1 divided by 2 times square root of x. And that was the answer for the derivative of square root of x that we got by using the limit definition. But notice here, by rewriting as a power x to the 1/2, using the power rule, this takes seconds. A true, legitimate shortcut. All right, now with that out of the way, notice it's again very easy to differentiate this if you first rewrite the function. Well, let's go ahead and do that here. The derivative that we're calculating is the derivative of 1 divided by x to the 4th. Well, recall from algebra, if you have 1 over a power, you can rewrite that as the variable to a negative power. So let's first rewrite before we differentiate. And I'm going to write that function as now x to the negative 4th power. And now we can apply the power rule. So the power rule still works if first the power is a fraction, and it also works for any real number. Like here, you might have a negative power. So we're going to apply it the same way. We're going to bring the power down. We're going to bring down -4. And just be careful, we take our exponent and subtract 1 to get the exponent for the derivative. So the new exponent would be -4 minus 1. And that should simplify -4 minus 1 to -5. So we get as our derivative -4 times x to the -5th power. Now, if you want, you can rewrite this And that will be beneficial later in your Calc 1 course. And let's go ahead and do that. I'm going to rewrite the negative power in the denominator. And I can write this derivative as negative 4 over x to the 5th power. Be careful, it's only the negative exponents that go into the denominator. Here, the negative 4, that's really in the numerator. All right, so here, the key step to make this easy. Again, we were rewriting the function before you differentiate. Now, a little bit later, you're going to learn about a rule for differentiating fractions called the quotient rule, but you don't need to apply that here because you can just rewrite your function as x to the negative 4th. Rewrite it as a power. All right, let's take a look at the last example here. It's pretty much the same as above, but a little more complicated because you're going to get now a negative fraction for the power. So let's first rewrite this before we differentiate. We have a power of x in the denominator. I can rewrite that as x to the negative power. So we'll rewrite that as x raised to the negative 3/2. And we still apply the power rule the same as before. So we take our power, which is now negative 3/2, we're going to bring it down front. So we get negative 3 over 2. And then times, I'm going to write this out. A lot of students make a mistake here. We're going to have as our exponent negative 3/2 minus 1. And the calculation, get a common denominator, and you should be able to write that power now as x to the negative 5 over 2, or negative 5/2 power. So our derivative here, we have negative 3 over 2 times now x to the negative 5/2 power. And there we go. All right, now make sure you, again, understand how the power rule is being applied to all these examples. The power rule works where n is any real number. Could be a nice power, like a positive integer in the first set of examples. Maybe something where you have x raised to a more peculiar power, like fractions and irrational numbers. And the power rule still works if you first rewrite your function and then apply the power rule. We're going to be using the power rule for a lot of other problems. So again, make sure you thoroughly understand it, and you'll be all set to do well in your Calculus 1 course. Hope you enjoyed the video and all the examples that we went through. Hope you're learning a lot. If you are, support the channel, like and subscribe.